Hello friends, in last lecture we will discuss the crystal field theory and assumptions of crystal field theory and shape of d orbital. In shape of d orbital, the 3d orbitals having the same shape and 2d orbitals having a different shape. The name of three same orbital is the dxy, dyz, dxz, and the two orbital, that is the dx square y square and the dz square orbital. This is the name of the 5d orbitals we are already discussing in our last lecture. In this lecture we will discuss the splitting of d orbital in octahedral complexes or splitting of d orbital in octahedral complexes. The question may be asked in a semester examination, that is, explain the splitting of d orbital in octahedral complexes, or they explain the structure to explain the splitting of d orbital in octahedral complexes. So, in answer, I explain here, listen carefully. Let us consider when the d orbital is placed in a octahedral field environment. Let us consider when d orbital is placed in a octahedral field environment. In octahedral complexes, the coordination number of the complexes is 6. In octahedral complexes, the coordination number of the complexes is 6, and the 6th ligand is approaches towards the central metal atoms. See here, this is the 5d orbital, or this is the 5d orbital, 1, 2, 3, 4, 5d orbital, or this is the central metal atoms. The 6 ligands approaches to central metal atoms, or approaches to the central metal atoms for the bonding formation. That times the ligands comes towards the central metal atoms in each of the direction or each of the axis, that is the x-axis, y-axis, z-axis, x-y-axis, and the z-axis. All the directions the 6 ligand comes towards the central metal atoms. Due to the electrostatic attraction between nucleus of the central metal atoms and negative dipole or the negative charge present on the ligands. Nucleus of the central metal atoms, nucleus having positive charge, and negative elements or the negative ligands having the negative dipole or the negative charge. The net electrostatic attraction between these two nucleus of central metal atoms and negative charge of the ligands or the negative dipole of the ligand, but due to the presence of, or there is the presence of the repulsion force between the electrons present in the d orbital of the central metal atoms and electrons present on the ligand, because electrons carry a negative charge and d orbitals electrons present in the d orbitals having the negative charge. These two negative charges repels to each other. And due to this repulsive force, all the d orbital is affected, but all the d orbital or the 5d orbital is not affected equally. Why it is not affected? Because the d orbitals, see here, 1, 2, 3, 4, 5, dxy, dyz, dxz, dx square, y square, and dz square orbital. This is the 5d orbital. Those orbital along the axis, for example, those orbital along the axis, which is 2 orbital along the axis, dx square, y square, and the dz square orbital, which is directed towards the along the axis, they interact ligand directly, and due to this direct interaction of the ligand to the d orbital, dx square, y square, and the dz square orbital, hence they having the high repulsion, or they feels the repulsion is more than the dxy, dyz, and dxz, because the dxy, dyz, and dxz orbitals, their lobes is present in between the x and y axis. Hence, they are not directly interact with the ligands. They are not directly interact with the ligands. Hence, they have not feel the very much repulsion with that of the ligands. Due to this, the energy of the d orbital or the energy of the Eg orbital is or energy of the EG orbital is increases, energy of the EG orbital is increases, and energy of the T2G orbital is decreases. Due to this repulsion, or due to this electrostatic attraction, there is the splitting of d orbital is take place. There is the splitting of d orbital is take place, and splitting of the splitting of d orbital. This is the d orbital hypothetical ions in a spherically symmetric field. This is the d orbitals having the higher energy. This is the d orbitals having the higher energy. The first of all here, the d orbital of the 3 metal ion. This is the d orbital having the degenerate orbital. This is the d orbital having the degenerate orbitals, means the 5d orbitals having the same energy, or 5d orbitals having the same energy. It is called as the degenerate orbital. After or when the 6th ligand approaches, or when this 3 metal ion is placed in a octahedral field environment, that time energy of the d orbital is increases. And when the electrostatic, due to this electrostatic repulsion, or due to this electrostatic repulsion, the T2G orbital and the EG orbital is split up, and this d orbital is split up into the EG orbital and the T2G orbital. The EG orbitals consist of the 2 sub-d orbital, that is the dx square y square and the dz square orbital, and the T2G orbital consists of the 3d orbital, dxy, dyj and the dxz. These 3 orbital, or this d orbital is split up into the 2 sets of orbital, or 2 sets of orbital. That is, first is the EG orbital and the T2G orbital. EG orbital consists of the 2 sub-d orbital, that is the dx square y square and dz square orbital, and T2G orbital consists of the dxy, dyj and the dxz orbital. EG orbital is directly interacting with the ligand along the axis, hence it feels the more repulsion, and it's raise the energy. And the T2G orbitals not feel the much or high repulsion force. Due to this, it's feel the lower, or its lower position than the EG orbitals. This is the barycenter. The total amount of the energy difference between these two, the energy difference between this EG and T2G is the 10 dQ, or delta octahedral. The energy difference between two orbital EG and T2G is 10 dQ, or is equal to the delta octahedral, and this energy is called as the crystal field splitting of octahedral in octahedral geometry. Or this energy is called as the crystal field energy of octahedral in octahedral geometry. The energy difference, this is the barycenter. This is called as the barycenter, or this is called as the barycenter. According to the center of gravity rule, the EG orbital is raised in energy, or the EG orbital is raised in energy by 3/5 is equal to plus 6 dQ, or 6 dQ, and according to the center of gravity rule, the energy decreases by the T2G orbital is 2/5, or is equal to the -4 dQ. These are the two differences from the energy barrier. From this energy barrier, plus 6 dQ energy is increased in a EG orbital, and -4 dQ energy is decreased in a T2G orbital. This is called as the crystal field splitting energy. The additional amount of energy is required to stabilize the complex due to the crystal field splitting. The additional amount of energy is required to stabilize the complex due to crystal field splitting is called as the crystal field stabilization energy. See here, CFSC. What is the CFSC? The additional amount of energy is required to stabilize the complexes due to the crystal field splitting. crystal field splitting झाल्यामुळे त्या मॉलिक्युलला ॲडिशनल अमाऊंट ऑफ एनर्जी जी काही लागेल स्टेबिलाइज होण्यासाठी त्या अमाउंट ऑफ एनर्जी काय म्हणतो आपण, दिस अमाउंट ऑफ एनर्जी इज कॉल्ड एज द क्रिस्टल फील्ड स्टॅबिलायझेशन एनर्जी, त्याला सुद्धा आपण क्रिस्टल फील्ड स्टॅबिलायझेशन एनर्जी. In this way, the splitting of d orbital is take place in a octahedral complexes or in a octahedral complexes. When the octahedral complexes in the centrometer atom is placed in a octahedral field environment, and octahedral field environment, the ligands number of the ligand is a 6, and these 6 ligand having the negative charge and centrometer atoms, d orbitals electrons having the negative charge, they have repulsed each other, but electrostatic attraction between the nucleus of the centrometer atoms and the ligands electrons. Due to this, the splitting of the d orbital is take place, and d orbital is split up into two sets of orbital. That is the Eg orbital, and this is the T2g orbital. Eg orbital is raised in the energy with the 3/5 is equal to 6 dQ, and T2g orbitals lower the energy by 2/5 is equal to -4 dQ. In terms of the delta octahedral, the 0.6 delta octahedral is energy of the Eg orbital, or -0.4 delta octahedral is the energy of the T2g orbital. In this way, the orbital is split up into two sets of orbital, Eg orbital and the T2g orbital. Eg orbital consists of the two orbitals, dx2 y2 and the dz2 orbital, whereas the T2g orbital consists of the three suborbitals, that is the dx2, dy and the dxz. This is the energy barrier center or energy barrier center. The total energy difference between T2g and Eg or Eg and T2g is 10 dQ is equal to delta octahedral, and this energy is called as the crystal field splitting energy or crystal field splitting energy. Then from the energy barrier, the energy is increased by +6 dQ to the Eg and -4 dQ to the T2g orbital, and total amount of energy or total energy, your energy difference is 10 dQ. In this way, the molecule is split up, and the additional amount of energy required to stabilize the complexes due to the crystal field splitting, this energy is called as the CFAC, crystal field splitting energy. This is the complete explanation of splitting of d orbital in octahedral complexes. See the second question. Explain the crystal field splitting of d orbital in the tetrahedral complexes. Explain the crystal field splitting of d orbital in tetrahedral complexes. This question is also asked in a semester pattern examination for the 4 marks. Say what is the answer. Imagine the tetrahedron. Imagine the tetrahedron is placed in a cube. Imagine the tetrahedron is placed in the cube. See here, this is the tetrahedral complexes, or this is tetrahedral complexes. And in a four corner, the four ligand is placed at the four alternative corner of the cube. See here, I place 1, 2, 3, 4 ligand. This is 4 ligand. 1, 2, 3, 4. 4 ligand is placed at the alternative corner of the cube, and central metal atom is placed in the center of the cube. Central metal atom. This is the central metal atoms. This is the central metal atom is placed in the center of the cube. See here, no any d orbital or no any ligand is directly phase or directly interact with the d orbital. They are away from the d orbital, or they are away from the d orbital. It means that the dx2 y2 and dz2 orbital, the dx2 y2 and dz2 orbital, it is the half edge of the face, or half diagonal edge of the face is away from the ligand, and the second T2 orbital dxy, dyz and dxz, it is also the away from the ligand, or it is away from the ligand. But the difference is that the lobe which is present in between the axis, that is the dxy, dyz and dxz, the lobe which is present in between the axis is nearer to the ligand, or they are near to the ligands, or they are near to this four ligand. And lobe of dx square y square and dz square orbital, it is away from the ligands, or it is not directly impact, or it is away from the ligand. But the ligands, or but the P2 orbital, that is dx dy and dxz, is slightly, or it is nearer to the ligand. Hence, it interacts with the ligands, or it interacts with the ligands, and the electrons present in the P2 orbital, that is dxy, dyz and dx orbital, dyz orbital, they are increased in energy, or they are forced to repel to each other, or they are increasing in energy, and splitting of the d orbital is take place. Splitting of d orbital is take place, and the splitting of d orbital is take place is exactly reverse to the octahedral complexes. Splitting of d orbital is take place is the reverse to the octahedral complexes. See here, the splitting of d orbital, the T2 orbital, this T2 orbital consists of the three suborbital dxy, dyz and dxz, and E orbital consists of dx square, y square and the dz square orbital having the lower energy, and dxy, dyz, dxz consist of the higher energy. This is the energy barrier center, or this is the energy barrier center. The total energy difference between T2 and E is the 10 dq. It is called as the 10 dq, or the delta tetrahedral is called as the crystal field splitting energy, or it is called as the crystal field splitting energy. From the barycenter, the T2 orbital or T2 orbital is having a plus 4 dq energy, and from barycenter, or the E orbital is lowered by the minus 6 dq or minus 6 dq. The delta tetrahedral having the lower energy as compared to the delta octahedral is equal to 4 by 9 delta octahedral. Means delta tetrahedral having the lower energy than the delta octahedral, because the less number of ligand is present in a tetrahedral geometry, because only 4 ligand is present in a tetrahedral geometry, and in octahedral geometry there are the 6 ligand. Hence the difference is arises this, or difference is a more, and splitting of d orbital is a reverse, or splitting of d orbital is a reverse. The energy barrier, or the energy required to this stabilization energy is required to this is called as the crystal field splitting in tetrahedral complexes, or crystal field splitting in tetrahedral complexes. The tetrahedral energy is less as compared to delta octahedral, because less number of ligand is present in a tetrahedral complexes, and maximum, or the 6 ligand is present in a octahedral complexes, and in tetrahedral complexes this 4 ligand is not directly interacted with the orbital. They are nearer to the orbital, or they are near to the orbital, only T2 orbital they are nearer, hence the energy of the orbital is increases, and in octahedral complexes the 6 ligand is directly interact with the T2 orbitals, hence this difference is arises. This is the complete explanation of the crystal field splitting of d orbital in the tetrahedral complexes, or splitting of d orbital in the tetrahedral complexes.